For this section, we're going to look at proportional reasoning. This topic is explored a lot in the elementary school grades, and it comes in the form of a lot of different types of word problems. So I'm going to introduce you to some concepts you've probably heard before about ratios and proportions, and then we're going to work on some word problems. So before we get started, our warm-up for today is which one doesn't belong. So looking at these four figures here, I want you to think about a reason why one of them doesn't belong with the rest. So the way that this is created is that there's a reason for each one, so there's really no way to be wrong, but you do have to provide a reason for why you think that. So these are all from the website Which One Doesn't Belong, so you could take a look on there for a variety of other ones for future experiences. So I'll give you a minute, pause it, think about a reason why at least one of them doesn't belong or more than one. So when I'm looking at these, the first thing that pops out to me in the first one here is that it's missing kind of some lines, like it doesn't have any kind of equal parts except for those two little boxes. I also notice it's the only one compared to the rest that has two that are colored in green. I notice when I go to this kind of fourth one here, it's kind of similar. It's not all equal pieces, but at least it's kind of broken up. It seems like it's the only one that is broken up where we see a triangle type shape going on. I notice on this guy over here that he's the only one that's breaking up really into thirds, because each of the other ones I can see really four equal sections. Even if they're not drawn for me, I could still see the four equal sections, so that's the only one that's a third. And then for this guy, I notice that he is the only one that's clearly identified to be the 1/4. And so that's what I noticed. So you might have noticed something different, but as long as you have a reason to back up what you're saying, it's okay to be different than mine. All right, so let's get into our content for today. So we're going to look at ratios. So the definition of a ratio is that it's this A over B, which it kind of looks like and does behave like a fraction. Sometimes written with that little slant, A over B like that, or A with the two little dots. And the way that we read it is A to B. So sometimes you'll see, like if we think about our class, I'm going to kind of skip down to some wording here, a part to a part. So like if I talked about the ratio of girls to boys in our class, then that would be about 20 to 7. And so part to part. So part of our class is girls, part of our class is boys. So the ratio would be 20 to 7. That's how we would write that. Now the ones that I skipped, they were have wholes to parts. So instead of just the part to part, we can look at the whole. Well, just one thing to notice, if there are just 20 girls and 7 boys in our class, then our whole number would be the 20 plus 7. So we have 27 students in our class. So if I wanted to talk about the ratio of girls to the class, then I could say that it is, let's see, the number of girls we said was 20 to the whole class would now be to 27. We could do the whole to part, so kind of the other way around. So the ratio of the class to girls is going to be now 27 to 20. So the order matters in these two things. But overall, all these is just a comparison of two quantities. Now, when we talk about the word proportion, that's just a statement that two given ratios are equal. And really that's going to look similar to saying two fractions are equal to each other, because when we set up a fraction equal to a fraction, and we want to look at this as a proportion, the cross product has to be equal. And again, that should seem really familiar. Now, the way that we read this when we're talking in terms of proportions and comparison of things is we say that A is to B as C is to D. So we're showing some sort of relationship. Okay, we're going to look at some more relationships. So I have a few examples here. So to answer the following questions, we want to look at the word Mississippi. So for all of these that are coming up on these next 2 pages, you should pause, read the questions, try it out, and then see how I worked on it. Okay, so please make sure you're trying that. Don't just follow along, but try them first. So push pause. Okay, so we're going to look at determining the ratio of vowels to consonants. So vowels are the A, E, I, O, U. So we have 1, 2, 3, 4 I's in there. So our vowels are 4, 2, 2, 3, 4, 5, 6, 7. The consonants are the vowels, or the non-vowels. So 4 to 7 is that ratio. So consonants to vowels, so just wants us to go the other way, 7 to 4, and then consonants to letters. So I noticed that without adding up all of them, that there are 7 vowels and 4 consonants, so there's 11 letters. So the consonants to letters would be 7 to 11. All right, for part 2, if we want to actually solve a proportion, we know that if these 2 ratios are equal to each other, that 5 times the 42 has to equal 30 times the x. So we have about 210 equals 30x divided by 30. We get that x is equal to 7. So really what we're saying when we read that fraction is that 5 is to 7 as 30 is to 42. They have this common relationship. All right, for part B, we have 3.5 is to 8. So I'm going to write 3.5 over 8. 3.5 is to 8 as x is to 24. So we know that it's setting up a proportion. When I look at this one, again, even though they're ratios and they're being called something different, they're still behaving like our fractions. So a kind of a quick way to do this is to notice that 8 and 24, they're off by 3. Like if I multiply 8 by 3, I would make 24. So if I multiplied the top by 3, then I'd have an equivalent fraction. So a fast way to do this is to say 3/2 times 3, which is 10.5. is what our x would need to be in order for those to be equal. But the alternate way is to just follow through with our cross multiplication. So 3/1/2 times the 24 is supposed to equal 8 times x, or 8x. And so we know that 3.5 times 24, well, you could do 3 sets of 24, which is going to be 72. And then take half of 24, which is 12, so we're going to get 84 altogether. So what I'm just kind of trying to do this mentally in my head, 3.5 times 24, that's 24 times 3, so 3 24s, that was 72. And then half of 24 is 12. So without a calculator, I was just getting that 84. So then we have 84 equals 8x, divide by the 8, and we get 10.5 is equal to x. Both ways are perfectly fine. I just think that first way was a little bit simpler. So let's see what number 5. There are 5 adult drivers to each teenage driver in Chino. So I'm going to write that as a ratio. So 5 adults to every 1 teenager. That's our ratio. So it says if there are 123,450 adult drivers, we want to know how many teenage drivers that will be. So if this ratio is holding, then I should be able to write this proportion that 123,450 adults, and notice I wrote it on the top because that's where the adult unit is. And then on the bottom, we're trying to figure out the number of teens. So we've just set up the proportion. So we'll solve this by again doing our cross multiplication. 5 times x will equal 1 times 1, 2, 3, 4, 5, 0. So we'll divide by 5, and so if we divide that, we end up that x equals 24,690, and so this would be the number of teen drivers that would help make this ratio hold. All right, for number 4, we have a candle that's 30 inches long. So I like to kind of draw the situation here. So here's my candle. After burning for 12 minutes, so it's burnt for 12 minutes. I'm just kind of thinking about, okay, after 12 minutes have passed, then it has lost some. It's now only 25 inches long. So Actually, let's think about this. If this whole entire thing is 30 inches, we're talking about a moment in time when it's now only 25. So it's only lost like a little bit. So in fact, we could say if it's 25 inches, then it's lost 5 inches. So that means that we know that for the 12 minutes, 5 inches were burned of the candle. So then we know that if we want to see how long it took to burn down the whole candle, that would be the entire 30 inches. We don't know how long it will take, so we'll put an X for that time, and then we know that that's for a 30-inch candle. So for as long as it's following that same rate, we can set that up. So then if we do our proportion, we're multiplying to solve this. So we know if those are equal, then 12 times 30 has to equal 5x. And so that's going to be 360 equals 5x. Divide by 5. We're going to get 72 equals x. So that means in 72 minutes, we will have burnt down that whole candle. So then for our next problem, we're looking at Juan, who found out that after working for 9 months, he had earned 6 days of vacation. So 9 months gets him 6 days. He wants to know how many days per year does he earn at that rate. So the rate is 9 months. He makes 6 days of vacation. And so it wants to know, okay, so for 1 year of working, how many days earned. Now, one thing to make sure you pay attention to is when you're writing your ratio, we need to think about what our units are. So these are in months to days earned. And so I want to replace the year with months. So then this will be 12 months. So then when we go to solve it, it should make a little bit more sense. So we solve our proportion. We're going to say 9x will equal 6 times the 12. So 9x is equal to 72. So we divide by 9, and we get x equals 8. So in 12 months, he earns 8 days of vacation. So that would be 8 days per year. Okay, we're going to try a few more. Again, if you haven't been pausing in between, try and do the problem yourself. So have it paused, try the problem, and then you can check it with my work. So should be pausing, checking. Okay, we're going to go back to number 6. So at a school, the teacher-student ratio is 1 to 30. If the school has 1,200 students, how many additional teachers must be hired to change that ratio to 1 to 20? Oh, that would be nice. So we know that there is 1 teacher right now for every 30 students. So if they have 1,200 students, we could actually figure out how many teachers they currently have, because then we want to find out how many more they need to add. So we can find out the teachers first. So we'll cross multiply so we can solve this proportion. So we're going to get 1,200 equals 30x. Divide by 30, that gets us that x is equal to 40. So right now we know that there are a total of 40 teachers for those 1,200 students. So then the question ends up, okay, that's great. So how do we find out how many we need to hire? Well, we know that we want the ratio to be 1 teacher for 20 students. And again, we still have the same 1,200 students, but it's just that we want this ratio to be a little bit smaller, or at least the number of students per teacher to be smaller. So we can find out the number of teachers needed and then think about how many we have to see how many more. So this will be, again, cross multiply. We're going to get 1,200 equals 20x. Divide by 20. It gets us that x is equal to 60. So in order to have that ratio, we need 60 total teachers. So if you go back, there were already 40. So 60 minus those 40 means that we're going to need 20 more of those teachers. All right, let's look at number 7. So they have a proportion set up for us already, and what they want us to do is find 3 sets of X and Y that will satisfy this. So we know that for every 4 tickets, it costs $20. So one of the easiest ways to do this is to think about what is equal to 4/20. I could just double that. That would make 8/40. But that would mean that there's 8 tickets for every $40. And then I could triple the original. So if I triple the original guy, 4/20, that could be 12. So I have 12 tickets for every $60. And so we're really saying the ratio of tickets to dollars, if you think about it, 4/20 can also reduce kind of the other way. 1/4. So that means 1 ticket costs, oopsie, not 1/4, but that would be 1/5. So 1 ticket costs $5. So I just found 3 different sets that would satisfy it. So we're saying X to Y for all of these, because X is the number of tickets and Y was the dollar. So we found 3 different sets that would all be making that proportion true. All right. Next situation we have Elizabeth bikes 18 miles in 2 hours. So her rate would be 18 miles for every 2 hours. Now Nick bikes 30 miles in 3 hours. So it wants to know who travels faster. So one of the easiest ways I think to do this is to try and simplify that little ratio that we have going on. So 18 miles for every 2 hours would mean that there would be 9 miles for every 1 hour, or in other words, 9 miles per hour. You've seen that before. And then 30 miles per hour, that can reduce to be 10 miles for every 1 hour. In other words, 10 miles per hour. So you can see that Nick is traveling a little bit faster. For number 9, we're looking at a recipe that uses 1.5 cups of flour to make 3 dozen cookies. So it wants to know if 4 cups of flour would be enough to make 6 dozen. So we know that we need 1.5 cups for every 3 dozen. And it's saying, well, if I have 4 cups, well, that makes 6 dozen. Well, if you look at the number of cookies they want to make, we have 3 dozen to 6. That's just doubling the recipe. So that would mean we would just need double the amount of flour. So 4 cups is bigger than double 1/2, because if I take 2 times 1 and 1/2, that's going to be equal 3 cups. So I really only need 3 cups. So 4 cups is perfect. So yes, it's enough. All right, number 10 wants us to use what they call a bar model to solve each of the following proportions. So a bar model has us write the ratio. So we have 2 to 5 in like a rectangular form. So I'm going to take this and have 2 pieces to the other 5. I want to make them all equal, because I should have extended that a little bit more. Okay, so you could see that the ratio of, I'm going to make it very clear here, the ratio of blue squares or rectangles here to red is 2 to 5. So we got that going on. So now what it says is we are talking about having a quantity of 35 things, and we want to split it into that same 2 to 5 ratio. So what we're saying is we want 35 to be split here. So we have 1, 2, 3, 4, 5, 6, 7 rectangles. So if I take 35 divided by 7, that's going to be 5. So what we're saying here is that each of these little rectangles is going to now be a worth 5. And I don't need to draw it differently, but what we're saying is that I can split this up now where these guys are going to be part of the 2 in that ratio, And then we have these other guys being part of the 5. So if we want to write an equivalent ratio to 2/5, but know that we're talking out of a total of 35, we're going to have, let's see here, this will be 10 to 5 here times 5, that would be 25. So the ratio will be 10 to 25. So you can see the total is 35, but it's split to be equal to the 2/5. And so just if I want to check if it's really equal, remember we can just cross multiply. So 10 times 5 is equal to 25 times 2 because it's 50 equals 50. All right, we're going to try that again. This time we're looking at the ratio of boys to girls to be 6 to 5. So I have 3, 4, 5, 6 to 5. Let's make the girls here. 1, 2, 3, 4, 5. So 6 to 5. Now it tells us that we have 90 more boys than girls. So again, the green is the boys and the blue ones are the girls. And since they have 90 more, you can see that we're bigger over here. The boys are bigger by 1 box. That means this has to have a value of 90. So if we want to know the total number of students in the school, we have to fill in and say, okay, well, that means each of these blocks was worth 90. And so then the total number of students that we're going to have will be, well, 90 times the 6. This is telling us that we have 540 boys. And then 90 times the 5, that's 450 girls. And you can see the difference between these two is 90. So that's what we said, that has to be 90 more boys than girls. The ratio of boys to girls, that's 540 to 450, is supposed to equal 6/5, which you can check. And so then that means our total number of students will be the 540 plus the 450, so we're going to have 990 students. And that's it.